Hi, today we're going to talk about proportional fractions and tables. So first we start with our bell work. Solve this big equation, and then the next one is to solve and graph the inequality. So first we're going to distribute 3 times x is 3x. 3 times a minus 4 is minus 12, so 3x minus 12. I do not multiply 3 times 2 because 2 is not in the parentheses, so I still just have plus 2. Equals, let's combine like terms. 4x plus x is a 5x minus 7. Over here I can combine like terms. Minus 12 plus 2 is going to be a minus 10. So I have 3x minus 10 equals 5x minus 7. There's an x on both sides. I don't like that. Choose one to get rid of. I choose to get rid of the 3x. So now I have a negative 10 equals 2x minus 7, and it's a two-step equation. Add 7 to both sides and then divide by 2. It looks like it might end up as a decimal. Okay, and then the next one is a two-step inequality. Subtract 5 on both sides. 13, 12, 11, 10, 9, 8 is greater than negative 2x. Divide both sides by negative 2 to get negative 4. And an x, but because we divided by a negative on both sides, we have to flip the direction of the inequality sign. And then we can graph it at a negative 4, open circle. If negative 4 is less than x, that means x is bigger than negative 4. So that's our bell work. Our goal, I can identify proportional fractions. This is the first goal. There's actually 2 goals in this. Rule, fractions are proportional if they are equivalent. That means when you simplify them, here, let's do this next sentence, which means they simplify to the same fraction. So they represent the same ratio. That number is k, the constant of proportionality. The constant of proportionality. But that's a really long word. It really just means what did these both simplify to? What's the ratio that they're both the same as? It's k, it's whatever they simplify to. It's the constant of proportionality. So some examples, we can simplify 12 over 18 to get 2 over 3. We can simplify 10 over 15 to get 2 over 3. They are proportional, and the constant of proportionality is 2 over 3. That just means this represents 2 over 3 and this represents 2 over 3, right? Simplify, simplify, and the constant of proportionality is now 4 over 5. That means both of these fractions just represent 4 over 5. Now over here when we simplify, we do not get the same thing, so they are not proportional, so there is no constant of proportionality. So now we can practice. We can simplify each of these fractions and then decide if yes or no they simplify to the same thing, and if it's a yes, they are proportional. So 14 over 18 simplifies to 7 over 9. 35 over 45 simplifies to 7 over 9. So they are proportional, and the constant of proportionality is 7 over 9. 4 over 3, I can tell you that's as simplified as it gets. So it's just 4 over 3. 24 over 18 simplifies to, I got to simplify it a couple times, to 4 over 3. Now I will say it actually simplified to 1 1/3 on my calculator, but that is a mixed number and it's the same thing as 4 over 3, which is an improper fraction. So because these are actually the same number, it is proportional. Okay, 6 over 24. 6 over 24 simplifies, I had to do it a couple times, to 1/4. 10 over 36 simplifies to 5 over 18, which means no, they are not proportional. Then you can do the same process with the bottom fractions also. Okay, now here's the next step. To create proportional fractions, we want to make it so that both of these fractions, when I say both of these, I mean this one and this one, when they simplify, they'll be the same thing. Now this is something we did in 7th grade, and it is just solving proportions. We learned multiple strategies to solve. I'll use one strategy here and a different strategy here. One strategy was the butterfly method or the Band-Aid method, whichever vocabulary word you prefer, which is where we multiply 45 times W is 45W, and we multiply 27 times 35, and we get 945. And then just divide both sides by 45 because it's a one-step equation. And we find out that W, whoopsies, is 21. So that means the fraction 45 over 35 is similar to or is proportional to 27 over 21. That means if we simplified 45 over 35, we're going to get the same thing as when we simplify 27 over 21. Now, that was, again, butterfly or Band-Aid method, whatever vocabulary you like to use. And then here's another one. It's called fish method, where we start in the fraction where the letter is, but I'm going to start with the number here. I go diagonally up, and then down to the other number, and then back up. See how we kind of create a fish? I multiply the first two, and then I divide the next one. So 90 times 13, and then I divide by 18, and I get 65. So again, now we know 13 over 18 is proportional to 65 over 90. So these are similar fractions. Okay, so same process that you could do over here. Now create your own two proportional fractions. Well, this sounds difficult. It's actually so easy. Like, for example, let's start with the fraction 5 over 7. If I want to make something that is proportional to that, well, I could just say, hey, I'm just going to multiply both of these by 2. This is one option, right? And boom, I have created two proportional fractions. A different way you could do this is let's start with like 6 over 15. And you say, I don't know, I want this to be a 45, but I don't know what needs to go here to make that work. Well, then you can use your solving proportions from before. I like the fish method, so I'm going to multiply 45 times 6 divided by 15. That gives me 18. Okay, so either of these strategies here, you start with a fraction and just choose the multiplier. So choose a number to multiply by. I chose 2. Or choose 3 numbers and then fish method or butterfly method to solve for what the missing number would be. Either of those is great if you're just creating your own fractions. Okay, that was our first goal, identifying proportional fractions. Now we're going to identify proportional tables, and it's actually going to be very similar to fractions. It's going to be all about simplifying things. So divide each coordinate point. The way you have to divide it is y divided by x. You could also write it like this, y divided by x. But the reason I like it like this is because it looks like a fraction. And that's exactly what we were dealing with before. If it is always the same number, so again, that means if when you simplify this fraction, it's always the same. Now you could divide like this and get a decimal, so maybe it's always the same decimal. Either way, simplifying all the way or getting a decimal, if it's always the same, then the table is proportional, and that number is k, the constant of proportionality. We use that a lot in this lesson. Actually, in the next few lessons. Constant of proportionality. There we go. So let's look at some examples. Here, I write the fraction y over x to remind myself it's the y value divided by the x value. We make this fraction, simplify it. If it's the same every single time, then yes, it's proportional. The constant of proportionality is 2. In fact, we can even write an equation. It's just y equals whatever number you just got with an x next to it. That's the equation. But if when you divide y divided by x and you get something different, even just one of them being different, boom, automatically no, it's not proportional. So we can do it ourselves. Y divided by x, 6 divided by 1 is just 6. 12 divided by 2 is 6. And 48 divided by 8 is 6. So yes, this is proportional. The constant of proportionality is 6, and we can write the equation y just equals 6x. Okay, 15 divided by 5 is 3. 18 divided by 6 is 3. Now if we just stopped here, then cool, it looks like we're good to go. This is proportional. Don't do that. You've got to check the last one, because if we check the last one, 24 divided by 7, ooh, that's 4. Not, actually, that's going to be like a decimal now that I say that. That's 3.4. 3.4, which is not the number 3. So no, sorry, not proportional. Now, sometimes the tables are going to be on their side like this, and this feels challenging. The reason it feels challenging is because we want to do x divided by y. But that is not correct. We still have to do y divided by x, even though it feels like we should be doing it the other way. So here we have to do y first divided by x. Y first divided by x. Y first divided by x. And we would check each of these to see if it was the same number. Okay, same process as before, dividing to find out if it's the same. If we only did the first few, it would look like, yeah, it would look like it's a 5, it's a 5, it's a 5. We must be good. It must be a constant proportionality of 5. But then when we get to the last one, oh, never mind, it's 1/5. Even though it has the number 5 in it, it's not the same thing, so that is not proportional. And then over here, I don't know, this looks weird. 23 divided by 5. 31 divided by 7. Nope, 2 different numbers, not proportional. Okay, so neither of these are proportional, actually. Now create a proportional table. Again, it might feel challenging. It's not. Let's just do like 1, 2, 3. And we can choose what to multiply by. Let's multiply by 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. Boom, proportional table. Because we chose the number 2 to be the thing we multiply by, that's K, our constant proportionality, and that's the number we put into the equation. Y equals 2, because we chose 2 to multiply by, with an x next to it. And we end by simplifying. 14 over 28, 16 over 32, this simplifies to 1/2, and this simplifies to 1/2, so yes, they are proportional. 14 over 2 is 7. 28 over 4 is 7. 42 over 6 is 7, and 70 over 10 is 7. So yes, this is proportional. The constant of proportionality is 7, and we could even write the equation y equals 7x. Great job today, you guys. You got this.